Now we show how to start the actual acquisition with the scanner. First of all, we see how to put the object under the camera. We already mounted the camera on the scanner, so it's connected through an USB cable to the computer. Also, the camera is powered. There is an external power supply because we want to use it for a long time, so we don't just want to rely on batteries. Basically, the camera, we have here this distance that is basically about 60 centimeter. And if we want to get a lot of details, we need to put the camera as close as possible to the object. So basically we want to use the minimum focal distance of the lens. In this case we have a 50 millimeter lens, so the distance will be like 40 centimeter. So basically here you have all this volume where you can put your object closer or more distance, or using all this distance. So the object could be standing here. So for example, we have here, we will work with this historical map of Jerusalem. And the idea is we want to have this high resolution image, very detailed, of this object. So the idea is that we could put the object over here, but as you can guess, we will have a very little resolution. So we go here on the computer, and we turn on, this is the software controlling the camera, is the Digicam control system. So we can go in a live view. So this is the view from the camera. The image is out of focus, so before we proceed we can focus it better. Okay, and there it is. So basically what happens here is that we see basically all the map in just one picture basically. The idea is we want to have more resolution, because otherwise the image, we cannot get with just one image all the details. So the idea is we want to raise the map, so we remove it. We can use any boxes, stuff, just to hold the system, the map in a position to raise it. So I'm building basically a stand for this specific work. Okay, so we can put also black cloth, so to avoid reflections. Okay, there we are, and then we can put the map for our documentation. Okay, there it is. So now we look at the computer and we see just the map. We get just a tiny bit of all the object. So we can check the focus. Okay, let's magnify, so to even have a better focusing. Okay. Okay, now it's pretty crispy, focusing. I get back to the old view. Okay, so first of all, we want to set up the photographic conditions. So like a normal photo. So of course here, for example, the image is overexposed. So we want to reduce the shutter speed. So for example, we go over here, 1/10 of seconds, maybe two less. Okay, 1/6. 100%. Okay, so go back. Okay, there it is. So basically focusing, we check the aperture of the camera. Let's see if it's Now the aperture is a 5.6, so that is what is called a sweet spot for this lens. This is a 50mm lens, so it's generally the aperture that I like to take photo because they have less aberration, chromatic aberration, distortion. Okay, at this point what we do is the camera is set up. I close the camera and I go into here in this software, in Digicam control. I go into camera property, and I go down to keyboard trigger. So the idea is is that we want to have the scanning software to automatically trigger the camera for the shooting. So we set up everything, and then the camera, the scanner acquires all the images. To do this, we need to set up the keyboard trigger. So in this case, for example, we go here on the software, we can have a combination like Control A, Alt, and other things. I suggest to keep it simple. So we say here, you see, we can choose which letter to apply. So the control, let's say we want to have very simple, just the letter A. And we don't want to have Control or Alt, just the letter A. I do save, and I must be sure that the live view is closed. So you see from here, the bottom of the top, I click live view. This is live view, so I can see my hand over here in the monitor. I can close it, and basically what I can do is if I press A on the keyboard, the camera is taking a photo. There it is. Okay, so the keyboard trigger of the camera is set up. Now we can move to see how the camera, how the scanner is controlled by the laptop and also the camera. Okay, so we go here in the Panorama control, we click on the software to control the scanner. You see the software is already connected, so we see already it's operating. Just to be sure, we can click this button to move up and down. We see the motors are working, so it's pretty nice, it's connected. We now discuss a next step to prepare the system for the acquisition, which is the FOV settings, the field of view settings. So in our software you find this FOV here in the camera control window, and over here you see there is a number. Right now is 100. You can input the number if you already have it, so we can put 2000 for example. This number must be actually calculated. We will do the process with a simple process right now. Once you have this number for your specific setup, you can use it and input directly. Otherwise, we want to calculate anytime. Okay, so what we do is we need to connect the camera to the laptop. So we use, as usual, a Digicam control. So the camera, we turn on the camera. Okay, the camera is on, so now we can go into live view. Okay, so this is live view, so the camera is here, you see my hand is alive. What we want to do is to choose a reference point. So for example, let's say this line over here, this borderline. So I put this Archimedes sticker, it has this arrow. So this line will be our reference. So first of all, we want to have this point, this line on the top of the image. So basically what we do is we move the camera so that the line goes to the top of the image. Okay, there it is. When it's there on the top, we click this button over here, set Y endpoint 1. So now this point has become green. So it means we have input this position. Now we want this line to go down in the image. So it means the camera has to go up. Okay, so I'm moving the arrow to the up direction. So the line goes down. Okay, so it's almost there. Okay, there we are. It's almost to the bottom part of the photo. Okay, there it is. Once it's there, we click Set Y endpoint number 2. So you see now we have here in this box this number 4464. So this is the field of view of this camera setup. So this field of view, basically we saw is this the distance, vertical distance, will change if you change the length, if you change the distance from of the object from the camera. So if you keep always this setup, you can just store this number, just note it down, 4464, and every time you turn on the software you can use this number. If you change the distance, if you change the length of the camera, you need to make this number again, to calculate this number again. Okay, so this is about making the field, determine the field of view of your photographic setup. This is an important parameter we have to determine at the beginning before doing the actual scanning. We are now ready to start the acquisition. So basically this software, the scanner software, works under the principles of a panoramic photography. So basically when we do panoramic photography, you won't tell to this panoramic head, so basically the machine that has to move the camera, what is the upper left corner of your panorama and the bottom right corner of the panorama. So here on the software main window we have Panorama Settings, and you see there are two buttons, Set Top Left Corner and Set Bottom Right Corner. So basically what we do is we turn on the live view from the camera, so we see our camera, and first we move the camera to the top left corner. So the camera goes up like this. We can actually use the mouse of the keyboard on our laptop, the arrows in our keyboard, so to move the head. So the head now is going up on the map, on the upper part, and then we will move to the left. Okay, maybe we can just adjust a little bit. Okay, just the angle of the map. Okay, we are almost to the top of the map. Okay, there it is. This is the top of the map. We want to have a little bit of a margin, and then we move to the left corner. So we are on the top left corner. Okay, we are passing the middle part of this map. And remember, this is the speed of these motors, so we chose to keep it relatively at this speed because anyway the area that we have to cover is pretty small. So, and this speed gives us a precision, which is important for this application. And also we don't want to have a very speedy things moving over our object, so even if it takes a couple minutes to move across the object, I think it's still fine for our applications. Another things I want to say is that right now I have the laptop on the same table of the scanner. So this is not optimal because you know, when I'm digiting here using the keyboard, I'm moving the scanner. So it's better to have the laptop on another table, so it's not interfering and creating adding vibration. Okay, so this setup is just for the demonstration. Okay, we are on the border. Maybe we want to go a little bit up over there. Okay, so this is the top left of the map. So I click here, set top left corner. So basically the software is remembering these coordinates for the actual acquisition. Then we see with the software itself has please move the camera and set bottom right corner of panorama area. So we go down, all the way down on this map. Okay, so first we go down to the bottom. Take care, we cannot press both of them like down and right left together, so we need to do one movement at a time, otherwise the system will crash. Okay, so first move down and then we go to the right. Okay, so we reached almost the bottom part. We want to have a little bit of margin, couple of centimeters. Okay, now we can go to the right. And we are almost ready to start the panorama. So we wait a few seconds. Always look at the camera while you do these movements, so be sure that there are no cables on the way. Okay, so always be sure that everything is going smooth. Also, because from the camera we have a cable is the power supply for the camera. Another one is the USB cable. Then the one in the middle is the power cable of the motors, of the X motors. So, well, basically there are just 3 of this cable to take care of. So, yeah, it's just be sure that they are not on the way. And we are almost there on the right corner. Okay, there we are. Okay, there it is. So now I'm on the bottom right and I click set bottom right corner. So basically now the software based on the field of view that is 4464, this actually is this number is the steps of the stepper motors used here. So basically based on this the software is analyzing this area and it says, you know, I need 9 images to cover all these objects. At this point we are ready to acquire, to start the photo sequence. So I click OK, and you see now the camera is moving to the left and then we'll go to the top left to start the acquisition from there. So basically the movement will be from the left top and then going down. Important things, these are very important for this acquisition. We need to close the live view, because otherwise the automatic shooting doesn't work. Then another thing we do need is to have this software, the scanning software, on top. So for example, what I do is I open the images folder, so I clean up, I delete all the other images. So this is the folder where the images will be saved. I want to have it on the desktop so I can see if the images are actually saved once they're shot. So we have the images, but be sure that your scanning software is not gray out, is black here. You see, for example, the title. If I click the folder, the software here, the title, becomes grayed out. So I need to click it, it's black, so it means that is the first software running the system. Okay, now the camera is moving up, it's totally on the left. Here on the setting, actually no, we cannot discuss the settings now. In the next video we will talk about these settings. There are a few things we can adjust. So far we are fine, so we should see the acquisition of our panorama going pretty well without any big issue. Okay, always check the position of the cable. We don't want to have them on the way, but they're fine. Okay. Okay, now we have almost reached the position. You see from the grid, the matrix grid. It's almost in position. Okay, position reached, first photo taken and transferred to the computer. There you are. So we see the images, and now the software will move to the other positions. So we are fine, and we'll proceed moving to the other things. So then eventually we can just have to stitch them together. Now basically we are moving to the last one of the acquisitions, and the scanning process is done. Just leave the scanner do its job. And there we are, so almost in the position. Last click, and so we have a photo taking sequence has been done successfully. So eventually over here we're going to see the 12 images we just took. Actually we can show them, let's see, like 3, okay, like this. So we have this column, then we have the other column, and then we have the third column. Okay, so we did this, we show how to acquire the images that then after that need to be stitched with a photo shooting, with a panoramic stitching software. We want now to discuss other settings where you can plan better depending on your your task, the acquisition. So basically we go in the settings over here, and here there are the parameters that you can change. We start from the top. On the top we have motor port, pan motor, tilt motor. So basically this one you don't have to change them. Basically they are already set up to work with this scanner. They control what means basically the forward direction for these motors. So this one you can leave as they are. If you change them, what happens is that instead of going forward, the motor will going backward. That's it. Okay, so let's leave them as they are. So basically the default position. Then we move in the camera control, this tab over here. So speed, desired speed, default value 100 revolution per minute. So you can leave this one. 100 is basically the maximum speed of these motors. You can go less than that, but then the system will be too slow. So this one is good, the maximum speed for this motor, and you can leave as it is. Microstep is another possibility, but we don't. You don't need that. Is to have very more precise movements, but is really a lot, and then the motor becomes too slow for most of our applications. So Microstep is an option, but we don't want to use it. Then we have zigzag control, so this option that was checked last time. So this option basically is the option that allows you to save time. So remember, the scanner is making a zigzag scan movement. So it start from the top, acquires the images, and arrive here on the bottom. Then if you check zigzag control, it means that the head move to the next column, and from the bottom start to collect the images and move to the upper part of the column. Then it moves to the third column, and from the top goes down and also acquire the images. So basically the idea is with zigzag control checked, the system is acquiring images every time it moves. If you uncheck zigzag control, the system will acquire the images going from the top to the bottom. So we'll start from the beginning on the top, taking the images, arrive at the bottom of this column. Then it moves to the second column, and it will go up on the top of the column without taking the images, and then from the top will go down. So as you see, it's making more travel without acquiring images. So it's nice because you will have immediately a plan of the images. You can tell from the folder, but it's taking much more time. So definitely I suggest to use the zigzag control checked. Then we have release on idle. I suggest to check this one also, because basically this means that once the motors have done the movements, they are released. So basically they don't eat up, so they don't consume energy, basically. So because we don't need to have them on all the time. That's the thing. So you can check this one, release on idle checked. Then we go into camera ratio. Camera ratio, so right now the default is a 3:2. This is because basically what happens is that you could have different kind of digital cameras on the scanner. So most of the standard photographic cameras, they have a ratio 3:2. Could be that you want to put here an InGaAs camera to do infrared reflectography, and in that case these InGaAs cameras generally they have a ratio 4:3, that is over here. So in that case you have to tell the software what's the shape of the images in order to make the panoramic acquisition accordingly. For most of normal cameras, the ratio is 3:2. Then we have photo shooting, this tab. We have x-axis overlap, y-axis overlap. So basically the idea is how much these images should overlap, because I remember at the end the idea is that we want to stitch these images together. So they should overlap a tiny bit, a lot. So basically the idea is from here you can say the percentage that you want them to be overlapping. So now it's a 30%. For digital photography is a predefined value, so you have a lot of overlapping. So when you use a panoramic stitching software, it works pretty well and fast. Then in the same tab we have shooting delay. So this is very important. At least it should be 2 seconds. It's better even to have more. Let's put 4, for example. And the idea is that after the scanner has moved the camera in one position, instead of immediately shoot the image, to wait few seconds. So that's it, because of course the movement of the camera will introduce some vibrations in the system. So you want to have your image to be still. And so let's wait at least 2 seconds, even more, in order to have the system stable. Okay, and then basically we have over here photo shooting software. We discussed already this one in one of the previous videos, where we were discussing basically the acquisition, the setup of the system, the software, hardware and software setup of the system. Okay, so basically now these are all the settings you need to know about what you can do with the Archimedes scanner.